So I need my Excel again to make things a little bit quicker. Okay, so in this one here, they give you time and they give you current. So the times here are 15, 36, 52, 78, 104, 118. And the current is 4.39 amps, 3.66 amps, 3.18 amps, 2.54 amps, 2.03 amps, 1.80 amps. And then there's another piece of the table which is incomplete. It's log I. Now, just to be clear, this is the time in seconds. This is the current in milliamps. And then what they want in the last one is log of the current in milliamps. And they give you an example at the start, 1.48. So you can take out your calculator and you could type in log 4.39 and tell me what you get.
4.39.
Yes.
1.47.
What you see is that number there. So what they want you to do for 2 marks is to finish the table. So we type in log of the next one, which is this one here, and we get, can you check log of 3.66? No, that's not right, is it?
You didn't do the natural log.
Yeah, Excel doesn't, I don't know if it has it. Let me fix that. Is it 2 points?
Yeah.
Yep. Okay. Let me round it off to 2 decimal places as well. Okay, so if I just copy this down, there we go.
Yeah,
That's them all there.
Yes.
Yes? You got that, guys? Yeah? Now, next one is they want you to draw a graph. They want log on the y-axis and time on the x-axis. I say that again. They want log on the y-axis and time on the x-axis. So we highlight parts of it in Excel like this? Yeah, we can. Okay. Insert, chart, again, scatter, next, next, next. So the title is going to be log of current versus time. X-axis is time in milliseconds and the y-axis is current, current if you want, in milliamps. Is it? No, sorry, it's log of the current in milliamps. Say again?
Natural.
Yep. And that's the graph there. Now, what do you think the next part, what's wrong, Curly?
Line.
Yeah, the next part is to calculate the slope. Okay, so if we were doing this in the exam, we draw a triangle and then measure that y and then divide it by the
When do
length.
we know when to measure when to do the triangle and when not to?
In the exam, it's always, if they ask you to calculate the slope, they want the triangle drawn. Yes, I am?
It's in milliamps.
Milliseconds. Oh, no, sorry, it's not.
Oh.
It's just seconds. Well, the numbers are right, just change that to S instead of MS. Okay. Now, let's put in our line. So, Avenue, please write this equation down.
With the numbers, with the
Oh, no, with the colors. Yes, with the numbers.
Nice one.
So, let me explain the marks. Do you? Oh, okay. 2 marks for finishing the table. 4 marks for drawing the line. And then 4 marks for getting the M and the C. So the M is minus 0.0086 and the C is about 1.61. So in total now that's 10 marks. Now did you write down that equation?
That's all.
You got most of it, yeah? Now, in the question, they tell you this formula, which you know. They say I equals I0 E minus T over RC. And that can be written as log I equals minus 1 over RCT plus log I0. So can you now, Abinu, read the equation we worked out back to me? So it was log I equals, give me the mx part, minus
0.0086.
t, and get me the part at the end.
1.6.
Thank you. They want you to calculate I0. So if you look here, you got log I0 equals 1.6. So therefore, what would I0 equal?
I0.
Yeah. E to the power of 1.6. And what's that, please?
4.95.
4.95. Okay. Now, what do you think they want you to work out next? Well, next we have to use this part here to work out the OR. So you get 1 over RC equals 0.0086. And we know what do we know? Oh no, he wants the RC in total. So therefore, RC will equal 1 over this number. So can you type in 1 divided by this number?
I think it's minus.
Ah, but minus and minus, so I just looked at the numbers.
1.16. 116.27.
Okay, now, next he wants, so we have the I0, we have the OR, C, but now we have to find the OR. So can we think of any way we could find the OR here? Now, remember, we know the I0. Any ideas? Tell me what the I0 is. What is it?
8 to the power.
What is it?
8 to the power 1.
Yeah, which is what number?
4.94.
4.95.
Now, if you remember, this is one of these capacitor ones where the capacitor discharges. Okay. Now we know the current at the beginning. Do we know the voltage at the beginning?
No.
Ah, but we do because, well,
From the graph?
we could get it from the. Could we get it from the graph? Nah, not. Oh no, we're given it. It says it in the question. The voltage is initially 12. So he tells us in the question that the voltage at the beginning is 12. So therefore, what's the resistance at the beginning? Well, V equals I or. Yeah, so 12 over.
Okay.
So what's that?
2.2.
2.24.
No, 40.
No, I wrote down the resistance at the beginning, but you realise the resistor does not change, right? So although the current and the voltage is at the beginning, it's going to be the same resistance for the whole discharge process. So that's the OR. Now the last part is to find the C. Well, that's not going to be difficult because we know RC equals this, and we know the OR equals this, so RC should equal 116.3. So give me the C now. What's the C?
Simple.
4, 48.05.
What's the unit for C?
Capacitance. Farad.
Leave him alone, Curtis. Stop picking on Joseph.
I really hear that.
What?
Sometimes that way.
And then that's question now, that's number 5 done. Yeah? Okay, isn't it? Okay. So, let me just stop this.